Okay, I'm going to work out some sample problems on how to write names and how to write formulas for ionic compounds, covalent compounds, and acids. First, we're going to start out with ionic. We know that a compound is ionic because it contains at least one metal. Metals come from the left side of the stair-step line on the periodic table. So we're going to start out with CSF first. So our rules up at the top tell us for naming, number one, write the name of the first element. So if we look up CS on the periodic table, it says cesium. We spell it just like it is on the periodic table. This is not a proper name, so we do not use any capital letters. And number two, write the name of the second element. If it's a single element, change the ending to IDE. So F, we only have one element listed, so that rule applies. Instead of fluorine, we're going to write fluoride. That's it. The next one, iron 2 oxide. So rule number one, write the name of the first element. So Fe is iron. Underneath rule 1, it says if it is CuFeSnHgPb or CO, use a Roman numeral. The Roman numeral comes from our charge of our element. When we write formulas, we write the charge on top of each element and cross the charges. So now we have to uncross our charges. If we look at our formula for Fe2O3, this 3 by oxygen actually came from the charge of Fe. So next to iron, we have to write its charge. So we're going to put a Roman numeral 3. That's everything for rule 1. Now rule 2, write the name of the second element. It is a single element, it's only oxygen. Yes, there's 3 of them, but it's only oxygen. So it says if it's a single element, change the ending to IDE. So instead of oxygen, we write oxide. All right, and then for the third formula, Na2SO4. So again, name the first element. Na is sodium. SO4, so write the name of the second element. If it is a polyatomic ion, so SO4, it's not a single element. We have sulfur and we have oxygen, so it is a polyatomic ion. If you will look at the chart on page 226 in your book, or if you look on the website, there is a link to give you a copy of the list of the polyatomic ions. Or you can look at the link that will take you to a Quizlet app to help you learn your polyatomic ions. But you will know, look it up, SO4 is called sulfate. We spell it exactly the way it is on the chart. We do not put the IDE ending. So Na2SO4 is sodium sulfate. All right, so those are the 3 different types of ionic compounds. So now let's look at writing the formulas. Our first one is beryllium oxide. Our rule says write the symbol for the first element. So if we look at beryllium on the periodic table, it is Be. Number 2, write the symbol for the second element. Oxide is actually oxygen. It says cross the charges. So if we look on the periodic table, Be has a +2 charge. Oxygen has a -2 charge. So mathematically, when we have a +2 and a -2, they cancel out. Same rule applies in chemistry. So our final answer is just BeO. So really, rule number 3, where it says cross the charges, we crossed ones. And ones are understood, so we do not write those in. Number 2, copper 2 chloride. So we're going to look on the periodic table for the symbol for copper. It is Cu. Step 2, write the symbol for the second element, so chloride is Cl. There's a Roman numeral 2 in between copper and chloride. The Roman numeral tells us the charge of copper. It tells us the charge of our metal. So copper is a +2. If we look on the periodic table, chloride is a -1. So we have to cross our charges. When we cross our charges, we only cross the number, not the positive and negative sign. So our 2 is going to go down here to chlorine, and then we'll have a understood 1 down here at copper. So we would write this as CuCl2. Right. And then for our last one, lithium acetate. Let me erase this real quick. Write the symbol for lithium. It's Li. Acetate. It ends in ATE. So since it ends in ATE, I know that it came off my polyatomic ion sheet. So I'm going to look up acetate on the polyatomic ion sheet. You'll see acetate written 2 ways. You'll see it as C2H3O2 with a -1 charge. And you'll see it written as CH3COO as a -1. They write it the second way so that it's easier for you to draw a Lewis structure for it. And this is the one that I put an asterisk by is the most common way you'll see it. So lithium is Li, acetate, CH3COO. If we look on the periodic table, lithium has a +1 charge. We look on our polyatomic ion sheet, acetate has a -1 charge, so they cancel out. And our final answer is LiCH3COO. You could also write it as LiC2H3O2. You need to be familiar with both ways that this acetate ion is written. All right, so that's everything for ionic compounds. Let's look at covalent. Covalent compounds are even easier than ionic compounds. Definitely not as much work. We know that something is covalent because it contains 2 nonmetals. So that means both of our symbols are going to come from the right side of the stair-step line, or it could be hydrogen. So our first step in naming, we have ICl2. Write the name of the first element using the proper prefix. Never use mono on the first element. So if you will look in section 1 of your textbook, I don't remember the page number, or you can look at the link on my website for the prefixes for numbers 1 through 10. We only have 1 iodine, and rule 1 says never use mono on the first element, so we will just write the word iodine. Step 2, write the name of the second element using the proper prefix. It should also end in IDE. The prefix for 2 is di, so Di, and then instead of chlorine, we're going to change the ending from INE to IDE. So iodine dichloride. The next one, SCl4. Write the name of the first element using the proper prefix. We don't use mono, so here we would just write sulfur. Cl4, the prefix in chemistry for 4 is tetra. And then again, chlorine becomes chloride, so tetrachloride. We don't have any charges. We don't have Roman numerals. We don't have polyatomic ions. That's all there is to it. Writing formulas, just as easy. So we have phosphorus pentachloride. Rule number 1 says write the symbol for the first element. So the symbol for phosphorus is P. Write the number of the prefix after the symbol. We don't have a prefix, so it's just phosphorus. Number 2, write the symbol for the second element. So chloride is Cl. Write the number to the prefix after the symbol. Penta is 5. So PCl5. The next one, dinitrogen trioxide. The symbol for nitrogen is N. The prefix di means 2. Oxide is O. Tri tells us 3. So N2O3. That's it for covalent compounds. Very, very easy, very quick as well. And then lastly, we have acids. We know that a formula is an acid because it starts with hydrogen. If we look at a name, we know it's acid because it has the word acid in it. When naming acids, we have 2 different types. We have binary is our first type, so that means that there's only 2 symbols or 2 elements listed. So HF, we only have 2 elements, so that very first bullet is the rule that applies to this one. It says if it contains only 2 elements, write the word hydro. We're going to put the stem of the element and then the letters IC, followed by the word acid. So HF, we're going to put hydro. F is fluorine, but it says the stem of the word. So fluor, and then end it with IC, hydrofluoric, and the word acid. Again, no charges. We don't have to cross anything. The next example, H2SO4. So this is the second bullet. If it contains more than 2 elements, write the name of the polyatomic ion. So if we look on our polyatomic ion sheet, SO4 is sulfate. So then this bullet here says that the ion ends in ATE, change the ending to IC. So instead of sulfate, this becomes sulfic, and then the word acid. Right, next example, HClO. ClO is hypochlorite. So now we're looking at the last bullet under naming here. If the ion ends in ITE, change it to OUS. So it's hypochlorous acid. And that's it. Writing formulas. All acids begin with hydrogen. So carbonic acid, we know it's going to begin with hydrogen, so we put an H. Then it says, write the symbol to the second element, or the polyatomic ion. So carbonic, if we go back to our rules for naming, carbonic, it ends in IC. So that means our polyatomic ion is going to end, oops, I marked the wrong thing. If our acid ends in IC, then our polyatomic ion ended in ATE. So this is actually the carbonate ion. So if we look up carbonate on our periodic or on our polyatomic ion sheet, it's CO3 with a -2 charge. Cross our charges and use parentheses if needed. So looking on the periodic table, hydrogen has a +1 charge. If we cross our charges, this becomes H2CO3. All right, next is sulfurous acid. It ends in OUS. So if we go back to our naming rules, if the acid ends in OUS, then the polyatomic ion ends in ITE. So that would be the sulfite ion. The first rule 1 says all acids begin with hydrogen, so we're going to put our H, the +1 charge. And then sulfite ion is SO3 with a -2 charge. And then we cross our charges. So H2 SO3. And then lastly, hydrobromic acid. So it begins with this prefix of hydro. So when we see that, we should know automatically it's binary. Binary means it's just going to have two symbols. So hydrogen's one of them, and it has a +1 charge. Bromic. So this came from the periodic table. Br for bromine, and it has a -1 charge, so those cancel out. And we're left with HBr. And that is how you write formulas for acids.